Precalculus student, this video is for chapter 6.1, still transformation of sine and cosine function. I'm doing the last example of cosine function transformation of a cosine bx. So a would be -3 in this case, b is pi. Okay, a equal to -3. So how high would the loop go, the wave go? It would go, the amplitude would be 3, right? Because absolute of -3 is 3. What's the period? Period would be 2 pi over b. So b is the frequency. That means how much is it will show up in how many loop would show up, or how many complete cycles show up in 2 pi. So the in this case will be 2 pi over pi is equal to 2. So the period is actually just 2. So once I know that, I know the right endpoint is 2, the left endpoint is 0, because it always starts from 0. We don't have any left and right shift. So when we say we have a horizontal stretch, it's always stretching from 0. So 0, so the middle point will be 1, and then this will be 1/2. And this will be 1.5. We say 3 over 2. Okay, no pi because the pi's cancel. What is the maximum that it can go? Because the amplitude is 3, so you would have 3 and -3. And because this is a cosine and a less than 0, that means there's reflection. Okay, 3, -3. Reflection over the y-axis. So instead of the normal, normal cosine x would be like this, right? Loop down and then up and then down. But if you have a reflection, that means negative cosine x would be go down, up, kind of like reflect. So we start from -3. We go to the intercept, we go to the maximum, and then back to the intercept and go to the lowest. So when you graph this, don't do a line, because otherwise it really look like a V. It should be curved up. And then when you're facing down, it's curved down. Okay. So you see how you can get a nice, so just kind of like doing curve up. We call it concave up. Okay, so that is how you graph -3 cosine pi x. Pi is just a number, so it could be used as a coefficient of x. It's a horizontal stretch. No, it's a horizontal string, I think. So we haven't done left and right, translation, right? Up and down or left and right. So the last part of the transformation is to have all transformation involved. And the formula that we employ would be a sine bx minus c plus d. So minus c would be the right c. So minus c means right c. Plus d means up, up d. For cosine, it will be a cosine bx minus c plus d. And sometimes if it is in factor form inside, we would say b, open parenthesis, x minus c over b, or a cosine b, x minus c over b. So, earlier I say it is right c. Right c is actually not correct. It should be right by c over b. It needs to be factor as the real horizontal shift. Okay, so the horizontal shift is b over c. B over c. So again, we have 4 things now. So how should we do? We would talk about the amplitude, talk about the period, which is still 2 pi over b, and then we will check if a is less than 0. If it's less than 0, we do a reflection. If it's positive, there's no reflection. Phase shift. Phase shift is horizontal shift. It's c over b. So if it is written in a factor form, so this is the number that is the horizontal shift. If you have it, if it's not factor, then you do c over b. One way to do this, if you can't remember if it's b over c or c over b, or how do it's factor or not factor is, that's actually what I usually does is, if there is some number and a c inside, I really don't know what the phase shift is, I would actually just solve for it equal to 0, because if there is no reflection, no horizontal shift, the left point should be 0, right? Phase shift means how much the whole graph shifts, right? So like if it is sine, it's supposed to be like this. If there's a phase shift, that means you would to the right. That means you start later or you start earlier, right? So this part is called phase shift. Up and down means the middle line shift up and down. Maybe I should use decimal to explain it a little bit. Decimal, let's just do this. So if I have y equal to sine x minus pi over 4, let's say, you can see that the graph looks exactly the same. There's no change in period. There's no change in the amplitude, but the graph just start later, right? The red one is sine, go from here to 2 pi, but the blue one would be starting from pi over 4 now. You see that it's pi over 4 comma 0, and then everything shift pi over 4. The ending part, it used to be 2 pi, now is 9 pi over 4 because 2 pi plus pi over 4 is 9 pi over 4. And it's shift to the right if you do minus. Okay, the same for cosine. So if I of this and then say y equal to cosine x. This is a familiar one from 1 to pi to 0 to -1 and then up. But if I do y equal to cosine x plus, let's say, pi over 3, okay, you can see that the graph now is negative pi over 3. It start earlier, okay. It's shift to the left, and so it starts at it used to be start from 0 to have the maximum. Now it's here, and then it ends earlier also. It used to ends at the black curve is 2 pi. Now it end earlier at 5 pi over 3, that which is 2 pi minus pi over 3. So both the beginning point or the leftmost point and the rightmost point of a cycle change. And then so let's get rid of these two. What happens if I do add a number outside, sine x, but plus 1? You can see that it used to be, so okay, so this is the one where the midline is the x-axis. Now the midline become y equal to 1, right? The whole thing shift up. And the same for cosine. If I have cosine x like this, of this first, but if I do y equal to cosine x minus 2, the whole thing shift down, and then you can see that the new midline is y equal to -2. We call it the midline. Okay, it used to be the x-axis. So we have all these that we've written down. So amplitude, period, these are the old stuff that we know. The last section. Phase shift would be solving bx minus c equal to 0. If there is no plus and minus, there's no phase shift. It's 0. Left endpoint used to be 0. Now it become the phase shift, right? And right endpoint would be the phase shift plus period. Phase shift plus period. Vertical shift would be the last number d outside. Remember, inside is about period and phase shift. Outside is about amplitude and the midline. If you have a vertical shift of d, the midline would be d. And then the maximum would be from this midline at the absolute value of amplitude, and the minimum will be from the midline down in amplitude. Okay, so let's just get used to this phase shift and vertical shift first. So I have b equal to 1. So what is the phase shift? Phase shift would equal to just negative pi over 6, because it has to be a negative. So if it's positive, that means you flip it over. So that means left pi over 6. And what is the vertical shift? Vertical shift is down 2, right? So you have a new midline. The midline is y equal to 2. And for this one, this is a little tricky. What's the phase shift? Where does the graph start instead of 0? So it would be C over B, right? So, but I just don't remember how to do it. So we actually, as a shortcut, we just solve this equal to 0, and it will give us phase shift. It's very strange. You get the inside, solve it equal to 0, because this is the original starting point, original left point of the phase shift. No phase shift means 0. Then I do plus pi. So this would be pi over 2x equal to pi. How do I get rid of the 2 pi over 2? I multiply 2 over pi, multiply 2 over pi, right? So that we x equal to 2. So the phase shift is 2. Phase shift is 2. You just solve the inside equal to 0. It will give you the phase shift. This is x is the phase shift. That means what it used to be 0, used to be no phase shift, and now I have pi x over 2. What is the phase shift? That's like how you do. And our vertical shift is up 1, right? So the midline now is this vertical shift, y equal to 1. Okay, so far so good in terms of recognizing. So now I don't need to solve anything here because there is no b. If there's no b, the only number that shows up is the phase shift. If there is a b here that is not 1, then you just solve it. Okay. Phase shift is hard to master, but you have to know that if there is nothing add and subtract, there's no phase shift, it's 0, and then the end of the period for the whole cycle, right? In this particular case, the period is 2 pi, so the end would be 2 pi minus pi over 6. Okay. So let's do one with multiple transformation from scratch. So here, I have to recognize that this is A outside, and this is B. Oh, we don't have phase shift, so thank goodness. In the beginning, we don't want to do phase shift. But then we have a D. D is up and down. So amplitude is 3. Period is 2 pi over B, right? 2 pi over whatever that shows up. 2 pi over 1/2, just remember, is 2 pi times 2 over 1, that is 4 pi. So it is stretch multiple. Phase shift is 0. Vertical shift is 1. Because there's no phase shift, there is my left point is still stay at 0. My right point would be the end of the period. What is my maximum now? But which is different, right? Because I have a vertical shift, my midline is 1. Midline is y equal to 1. If I have 3 above 1, so it will be 3 plus 1 equal to 4. What is the minimum? It will be 1 minus 3 is equal to y equal to -2. So the way I would do it, it would be I would look at the left and right first. So it's 0 to 4 pi. Get this 4.5 point figure out first. So the middle is 2 pi. The middle is pi. The middle is 3 pi. Where the quarter point is 3 pi. Now I have to do not 3 and -3, but 4 and -2 because the vertical shift make my midline to be 1. So I'll do a midline of 1, right? And then I'll have up 3, so this is 4. It's not very in scale. And then down to -2. 4 and -2. So this is the middle. So now I'm ready to graph. There's no reflection, so it's a sine graph. So sine graph will be intercept. It is not an intercept, but the midline intercept, right? Midline intercept, maximum, midline intercept, minimum, which is -2, and then midline intercept again. So be like that. Okay, for one cycle, okay, it would go on forever. So presumably you should have forever. Some book asks you to graph 2 cycles, and you just repeat. Each quarter is pi, so you just say 4 pi like that. Okay, let's do the 5 key point. What's the first point? Is 0, but 1 because it's y equal to 1, right? And then pi to 4. At x equal to pi, y is 4. And then 2 pi, 1 again. And then 3 pi, -1, or actually -2, right? The minimum is -2. The last one is 4 pi in the midline again, 1. Okay, so that's the 5 key point. I don't think I have enough time to do these two examples, so I'll do it in the next video.